You know that from any source of light, light is transmitted in straight lines, and when an opaque object is placed in the path of light, it casts a shadow on the screen. Look at this picture. Do you remember the story from the Panchatantra about the lion and the rabbit? When the lion in the story looked down into the well, he saw another lion. It was the image of the lion formed in the water. How is an image formed? When rays of light fall on a surface, they turn back. This is called the reflection of light. For example, a rubber ball hitting a wall is turned back. That is reflection of the ball. Let us see how light is reflected. Take a simple electric torch. Stick a piece of paper having 3 slits over the glass of the torch. Spread a sheet of white paper on a drawing board. On one side of the board, place a flat or plain mirror upright. Now, place the torch on the board obliquely in front of the mirror at a distance of about 45 centimeters from it. You will observe 3 beams of light. Follow the path of the beams after reflection from the mirror. We can see how light is reflected. Now, look into the mirror along the line of the reflected beams. You will see the bright slits of the torch in the mirror. Thus, we can see that the beams are indeed the ones coming from the torch. What happens when you look at yourself in the mirror? Light rays starting from your face fall on the mirror, get reflected from it, and enter your eyes. That is why you see your face in the mirror. It's your image formed in the mirror. Let us try this. Place a lighted candle in front of a mirror. You will see a second candle in the mirror. The real candle is called the object, and the one in the mirror is called its image. The image formed in a plain mirror is upright. But is it of the same height as the object? Let's find out. Stand in front of a full-length mirror. Place your head in contact with the mirror. Measure the distance of this point from the floor. What do you notice? The image formed in a plain mirror is upright and of the same size as the object. Now, you saw that the image formed in a plain mirror is behind the mirror. But what is its exact location? Let us try this. Take a chessboard. Place only one piece, the queen, on it. Place a plain mirror upright at one end of the board. Now, place the queen in the middle of the 5th square from the mirror. Look at its image in the mirror. The image too is in the 5th square behind the mirror. Now, move the queen 3 squares further from the mirror. It is now at the end of the board. Where is its image now? The image too is in the 8th square. Thus, we can conclude that an image in a plain mirror is behind the mirror and at the same distance from it as the object. Now, let us study about the lateral inversion. Stand in front of a large mirror so that you can see your entire image in it. Make your friend stand next to the mirror as shown on the screen. Now, raise your left hand. Tell your friend to look into the mirror and raise his hand in the same way as the image. He will raise his right hand. Now, raise your right hand. Your friend will raise his left. It means that the right and left sides are interchanged in the image formed in a plain mirror. This is called lateral inversion. Thus, an image formed in a plain mirror is said to be laterally inverted. Example, the word ambulance is written on an ambulance in reverse so that the driver of a car can read it as ambulance in his rear view mirror and thus know that an ambulance is following his car. Coming to the next important topic, the laws of reflection. Let us perform an experiment to understand the three important laws of reflection. Spread a sheet of white paper on a drawing board. Fix a plain mirror upright at one end of the paper. Make a slit in a piece of black paper and stick the paper on the glass of an electric torch. Now, place the torch 10 to 15 centimeters away from the mirror as shown. Make the room dark. Switch on the torch. What do you see? A beam of light from the slit in the paper falls on the mirror at an angle to it. This beam of light is incident on the mirror and is shown by the incident ray PO. Draw a line perpendicular to the mirror at the point of incidence of the ray. This line is called a normal. Now, looking at the ray of light reflected from the mirror, draw it on the paper. This is our reflected ray. Repeat the experiment 4 to 5 times with different angles of incidence. Look at the figure. PO is the incident ray. OQ is the reflected ray. OM is the normal. The angle that the incident ray makes with the normal is called the angle of incidence. Here, angle POM is equal to angle I, which is the angle of incidence. The angle made by the reflected ray with the normal is called the angle of reflection. Here, angle QOM is equal to angle R, which is the angle of reflection. Note down the value of corresponding angles of incidence and reflection from the 4 to 5 observations you made. Write the observations in a tabular form. You will notice that in each observation, the value of angle of incidence is equal to the value of angle of reflection. That is, angle I is equal to angle R. Also, the two rays and the normal are in the same plane. Thus, we can infer the following laws of reflection. 1. The incident ray, the reflected ray and the normal are all in the same plane. 2. The incident ray and reflected ray are on opposite sides of the normal. 3. The angle of incidence and angle of reflection are of equal measure. Light is reflected from smooth as well as rough surfaces. On the basis of this, there are two types of reflection. 1. Regular reflection. Reflection from a smooth surface is called regular reflection. Look at the diagram. Light is reflected from a smooth surface just like that of a plane mirror. Thus, we can say that when parallel rays fall on a smooth surface, their angles of incidence are all equal. Their angles of reflection too are equal. They are also equal to the angle of incidence. Such reflection is called regular reflection. 2. Irregular reflection. When parallel incident rays fall on a rough surface, the reflected rays do not remain parallel to each other. They get scattered over a wider surface. Thus, reflection from a rough surface is called irregular reflection. Let us try to understand reflection of reflected light. At night, you can see the image of the moon in a mirror. Which is this light that reaches your eyes? The sun's light falls on the moon and is reflected from it. It is reflected a second time from the mirror. This shows that light can be reflected several times. In a barber shop, there is a mirror in front of you and one behind you, and so the reflection takes place more than once. In fact, we get infinite number of images in such parallel mirrors. Now we shall study two applications which work on the same principle of multiple reflections. The first one is periscope. Take a plastic bottle and make 2 oblique cuts in it in 2 places, at the top and the bottom. Fit 2 plain mirrors in it parallel to each other and making angles of 45 degrees with the length of the bottle. Make 1-inch windows in the bottle in front of the 2 mirrors. Now look in through the lower window. We can observe the image of objects that are in front of the upper mirror. How does this happen? First, the image is formed in the upper mirror. It gets reflected into the lower mirror, which can be seen through the window at the bottom. A periscope is useful on a submarine for keeping a watch on things above, even while the submarine is below the surface of the sea. The second one is kaleidoscope. Take a long cylindrical case. Fit 3 mirrors inside it, making angles of 60 degrees with each other. Cut off the base of the cylinder and cover it with white kite paper. Put 4-5 pieces of colored glass into the case. Make a small hole in the lid of the box. Put your eye near the hole and turn the box towards the light. You will see a number of colorful images. Turn the box a little and you will see different colorful patterns. What makes this happen? 3 mirrors reflect the objects several times and we see several images. That is also the reason why we see these many patterns. Nowadays, we see lines of specific colors painted along the sides of a road. The paint used is fluorescent paint. When light falls on it, it shines. The lights are easily seen in reflected light and serve to guide drivers of vehicles when it is dark.